So today I wanted to talk about continuity. So continuity, and I'll stick primarily with curves today, but continuity is the same concept between curves as it is between surfaces. But I'd like to primarily talk about this through curves, and then we get into surfaces later. So continuity is how two curves are blended together. So I'll give you an example here. So I will throw in, I would expect you to have some knowledge of spline. So I'm in the CATIA GSD workbench. I've got some points already created. So I'm going to create two first degree splines. So I'll create a spline between the origin of my axis and also between this first point. And I'll create another first degree spline between this point and this point, just to begin with here. And I will throw around parallel to the screen so you can see it. So what we have here, since we got spline 1 and we got spline 2, they share a point here in common, so that's a co-points condition. And that's it. That's all they have in common. It's just that co-point condition. So that is referred to as G0 continuity. G0 continuity. So let's adjust this. So G0, again, continuity is just the sharing of a point. So let's adjust this and we'll move to what's referred to as G1 continuity, or you may hear referred to as tangent continuity. So I'm going to go into my spline, the second spline, and I'm going to look at my spline definition. So I've got point 1, which is here, and then I've got point 2, which is here. So I'm going to create a tangency condition at point 1 to this spline. So I can go down to show parameters, and I can create a continuity from a curve, and the curve I'm going to select is here. And then notice the continuity type I'm showing as tangent continuity. So the options under there would be tangent, which is G1, or curvature, which is G2. I want to leave it at tangency continuity. So if you're looking at my spline definition menu, I've got point 1. I've got tangents direction is to the first spline with a tension of 0. We'll get into tension later. So that, what is showing on the screen, is G1 continuity. So let me throw a porcupine analysis on these. So I want to hold down the control key to select both. Shows the curvature of my splines in this case. This first spline is a straight line. It has a power of 1, so it has no curvature to it. And so notice how you can't see the porcupine analysis. It's the case for straight lines. Here, this is a second degree curve. Okay, so notice we've got some curve going in. So you might think to yourself, well, I've got 2 points. A spline between 2 points is a first degree curve. You won't have any continuity, but I added a tangent continuity on the end here. So by adding that tangent continuity, I added a degree to my curve. So between 2 points, that would be a first degree, but when I added the tangent continuity, that added another degree. So this curve is a second degree curve with tangent continuity across this point. So that is G1 continuity. So I'm going to just play around with this just a little bit. So I'm going to come back in here. I'm going to take this, and I'm actually going to remove the tangency. So just get used to working with the spline definition tool. So you've got a remove point, which I don't want to do. You can remove tangency, or you can reverse your tangency. You can see the point here. Reversing tangency would do that. So I'm just going to remove my tangency, and so it took me back to each curve. It took me back to G0 continuity, and since each curve is a straight line, that's why I'm not getting anything on my porcupine analysis. So what I want to do here is just to show you a couple of different things here, or a few different things actually. So I'm going to go back to my first I'm going to go back, and I'm going to get rid of this line. I'm going to create a spline across here. I thought I had created a spline to begin with, but apparently I just created a line. So there's a spline. So notice it's a first degree spline. It has 2 points. Now I can come in. I can add continuity to these ends, including this end, in a couple of different ways. So I want to go to the first point. I'm going to rotate it around so I can see it in 3D a little bit better. So I'm going to go to parameters. I can go, you can try from curve, and you can pick this axis system. So notice I'm doing from curve. I can come into my element, can be the y-axis. Okay, so when I did that, notice I went from a first degree to a second degree curve because I added that continuity on the end. So now this curve is tangent to the y-axis as it leaves on the point. I want to remove that and show you another way you can do this. Go back to the first point, show parameters, and I'm going to remove the tangency, so it takes it back to a first degree line. This time though, instead of doing from curve, I'm going to do explicit. And so explicit here will allow you to either pick the y-axis again, or you can right click in here and go Y component. So Y component on my current axis system, it gives you something very, very similar. The main difference between doing from curve and doing explicit is, notice there's no ability to change to curvature continuity. You've just got, in this particular case, you've got just the G1 continuity. So take you back to the previous one. I can actually do. See, notice when I slicked in here, I cannot do y-axis. I cannot. There's no pop-up menu. So you have to pick a curve. In this case, the curve can be an axis, and it's not. I'm going to click out. It wasn't letting me pick that, and I'm going to remove it. Now it's going to let me pick. So I can come back out. I can do from curve. I can pick the y-axis, and now I've got tangency and curvature options available. Now, come back in here. Let's look at this from a porcupine analysis. So I can pick there, and that's just going to be a straight line, but I'll select it anyway. So notice, even though this has curvature, I've still got G0 continuity between these two. Now, I'm going to jump up here to this curve and just do some plane, if you will. I'm going to go to point 2 of this curve, and let's throw in an explicit continuity to the y-axis. So that should take this point, or will take this point, and the y-axis is going this direction, so it will make this curve come tangent, so the curve will flow around this way eventually. So I'm going to go, and I'm going to go explicit, and I'm going to go y-axis. I may have to reverse the direction. No, I don't. Sometimes it may come in that way, but notice what happens. That's good. So that's a tangency, and that curve is just going tangent to the y direction at that point. But still, I still have G0 across here. And you can tell that because these quills on my porcupine analysis represent the slope, and the curvature represent the curvature and slope of that point. And so notice their slopes are going in different directions, so they're not tangent to each other. So if you think of mathematically, when you have let's say you take a curve equation and you get the first derivative, that's going to show you a slope at a particular point. What you're getting when you have G1 continuity is that they will have the same slope at that point. So their slopes will be the same. You can think of that as a first derivative of each equation at that particular x component of that point, and then it will. And I'll show you that here in just a second. So let's go in, and I'm going to go back to this curve, and I'm going to go to point 1, which is the point here. I'm going to make that from curve. I'm going to make it go G1 or tangency to that point. So notice I've got now from curve, it's going to this particular spline, and I've got tangency continuity. Now see what happens. And let me blow up my porcupine analysis just a bit so you can see that better. So I've got the curvature of this curve, and then the curvature of this curve. Notice the quills are running in the same direction. They have the same slope. That is the only, that's what your porcupine analysis will show you for G1. The quill will be running in the same direction. That is all that shows you. Well, you got the curvature and you got the curvature, but as far as continuity is concerned, with G1, the quills are running in the same direction. Essentially, that means they have the same slope, which is G1, and G1 represents, from a mathematical point of view, it represents that you have the first derivative of that curve. So first derivative here, get it at this particular x value, and you're going to have the same slope. So just a little bit of theory of math, some calculus theory thrown in. So that is G1 across here. So let's change that to G2. So G2 represents curvature. G2 represents curvature continuity, so you can call it G2 continuity, or you can call it curvature continuity. I'll use both definitions. It is the second derivative. It is the second derivative. And what you have there is you have G1 continuity, which is tangent continuity, plus the same rate of curvature. Or if you want to look at it from a different perspective, the curves have the same radius at that particular point, only at that particular point. Same curvature or the same radius at that particular point. So what I want to do is I'm going to come back into this one, this curve. Right now we're sitting for point 1. If you look at your screen here, we got point 1, we got spline dot 3. And we've got, if I show parameters, I've got tangency continuity. And so if I change this to curvature, it's going to change it, and it's going to still keep the G0, which is point continuity. It's going to keep the G1, which is tangency continuity. So the G0 part is they share a common point. The G1 part is they share a common slope. And so what's going to happen is they're going to share the same radius at that particular point, or curvature, if you want to look at it that way. So boom, there's the change. So when I did that, so they are sharing the same rate of curvature. So notice at this point, and only at this point, the quill, they had the quill in common. This quill with a curvature analysis represents the amount of curvature at this particular point. So this curve and this curve are sharing the same curvature at that point. So with this set to G2 continuity or curvature across here, it has G0, means they share the common point. It has G1, which means the quill has the same slope, or the curve has the same slope. And also it has the same curvature. The quill represents the curvature. So the curvature is the same length for both curves at this point. Now also think about this. So this spline started out as started out with a degree of 1, or a straight line. It had 2 points. Okay, so it started out as a straight line. I added G1 continuity, which added a degree to the curve. And then I added another level of continuity, which added another degree to the curve. So it went from first degree, straight line, to a second degree, and then when I added G2, it made it a third degree curve. So every time you add a new level or an increased level of continuity, it adds a degree to the curve. What's the minimum thing you can, what's the minimum degree of curvature? What's the minimum degree that will give you a point of, potentially give you a point of inflection, and that's a third degree curve. So notice in this example, I am, actually it's a fourth degree, because think about it, I actually added, I have a degree here as well. So it's a fourth degree. Let me see what happens if I take and remove that tangency. So I took and removed that tangency. It is still so when I remove that tangency, I want to back this up a step, and I just want to clarify this because this is very important. I'm going to back this up to tangency continuity. Okay, so right now this curve is second degree, and it's second degree because it's between two lines, and I have tangency or continuity added here. So first degree and then add the tangency continuity makes it second degree. So it's a second degree curve, like a parabola is a second degree curve. I come in here and I've got a curve between a spline between 2 points. Okay. Then I added the continuity at point 1 and its tangency. So right now that's a second degree curve. It started out as first degree with the G0 continuity. When I added the G1 continuity, it added a degree to the curve. So that's second degree. And by increasing this to curvature, I just increased it to third degree. It has the potential for a point of inflection. That doesn't mean it will have a point of inflection. It just has the potential for a point of inflection. I can manipulate the location of these points and make it have a point of inflection somehow, but it doesn't have to have a point of inflection. It just has the potential for a point of inflection. So that is a third degree curve as it stands. By adding another tangency, and let's say I can't go any higher in the spline tool than G2. There is a such thing as G3, but you'll primarily find that in freestyle workbenches. So it only goes up to G1, it only goes up to G2, but I can add continuity to the other side to point 2 as I did before, and let's say I put that in the Y direction. Now I just added now that's a fourth degree curve. And when it does have a point of inflection, but it has the potential for 2 points of inflection, it just happens to only have one in this case. Now let's play around with a couple more things here. I'm going to go back to this spline. I'm going to go back to point 1. I wanted to show you this tension tool. So you have tangent tension. Right now there's just a tension value of 1, just a normal a unit tension there, just a tension value. So if I increase that, notice what happens. That is it's the same as pulling tighter on that point. Now, it doesn't change the continuity. It's still G2 continuity. It just changes how hard is that. If you want to look at it as a rope, that's normal. That's actually a rope that's extended out here. You can think of that as just how much harder I am pulling on that rope. It doesn't change explicitly the continuity. You can get it to a certain point where you can simulate another level of continuity, but I won't get into that today. But this tension value is very helpful for design purposes. So I'm going to leave it. You can actually decrease the tension as well down to 0, then you get an error message. To finish up this demonstration, I'm going to add another spline in here. Let's go from there to there. And let's create G2 across here. So that would be point 1. I can do from curve. And I can go to this element and then make it G2. Notice how it changes. I'm going to leave it at tangent for now. I'm going to take my porcupine analysis. I'm going to add that to it. So if I'm looking here, so as far as parameters are concerned, point 1, I've got tangent curvature. So that means tangency means it's G0 plus the same slope. So it's sharing the same point. That's G0. It's sharing the same slope, and that's represented by the porcupine analysis by the quills running parallel, or actually collinear with each other. Now the slope of the line is actually perpendicular to that quill running this way, but you can think of them as being the same slope by looking at the the quill itself. Now, if and when I change this to curvature analysis, the length of the quills will be the same at this point. So watch what happens when I do that. Boom, the lengths become the same. So it has the same curvature at that point. So that's the G0 part. And it's a much better, smoother curve with better reflections. So for Class A surfaces, and I'll get into Class A surfaces more later, but essentially a Class A surface is a surface that's visible by the user when the product is in use. You can think of an automobile, it's the body, most of the body of the car when it's in use. So the doors are shut, the hood is shut, etc., and you can see the reflection. So Class A surfaces typically will be G0 or G2 or better. That's usually going to be based on company standards, but that's the standard I like to use in my classes. It's G2 or better, and it depends on the product. You could have products that don't have reflections are not quite as important, such as maybe power tools. So you may have a company that says, hey, we want G1 or better to be our Class A surfaces. So it's really based on a company, but the automotive industry typically will use G2. Now you can actually go up to G3 for styling surfaces, nerves-based surfaces, but CATIA's GSD workbench for the most part stops at G2. I can replicate G1 by manipulating the tension tool, but that's another topic for another day. So that is the curvature. Again, keep in mind the things I wanted to highlight. You got G0, which is position, continuity. That means for curves that they have a co-point condition. You have G1, which is tangency continuity. That is G0 plus the curves have the same slope at that point. Then you have G2, which is curvature continuity. That would be G1 plus the same rate of curvature at that particular point. And then for G3, I do want to at least throw out the definition of G3. G3 is acceleration continuity. So you have position, tangent, curvature, and G3 is acceleration continuity. Acceleration continuity is G2 plus the amount of change of the curve along the curve. And I can't show you that in the GSD workbench, but the amount of change in the curve remains the same. So if we're looking here at this point, so notice this is G2. It has the same rate of curvature, so the quills are the same. But if you look at the backbone of the porcupine analysis, the porcupine analysis itself right here is a G0 type condition. If you wanted to increase this to be G3, then this backbone here would come tangent to each other instead of being G1, or sorry, instead of being G2 here. I want to blow this up even bigger. So instead of being right here, the top of the quill, the top of the porcupine analysis, this line and this line is G0 right here. If you make it G3, then these two lines would be tangent to each other. That's the effect you would get. So you can see that in other workbenches, the ISOM or the freestyle workbenches in CATIA, but the GSD workbench, you have to kind of simulate that. So that includes it. Again, remember how to do this in CATIA. Remember how to do it with a spline tool, and remember the four types of continuity: G0, G1, G2, and G3, and the last one, G3, is acceleration continuity. And also remember the degrees of curve: first, second, third degree, fourth degree. What's the minimum number? What's the smallest degree you can have and have a point of inflection? That would be a third degree. So please keep all that in mind. Thanks, and have a great day.